Welcome to The Explainer. So, have you ever wondered why an absolutely astonishing 77% of AI projects just completely fail? We see all these crazy headlines about revolutionary AI every single day, right? But behind the scenes, the reality is that most of these initiatives never even make it to the public. Today, we're unpacking exactly why that happens. And honestly, more importantly, how fixing this massive failure rate has basically created one of the most explosive, lucrative job markets in tech right now, with salaries routinely blowing past $257,000.
To understand how this all actually works, we're going to follow a quick roadmap. We'll start by looking at the AI production problem, define what MLOps actually is, map out its life cycle, compare it to traditional DevOps, and finally dive into that absolutely wild 2026 job market data. All right, diving right into the AI production problem. We really need to shatter a common illusion right off the bat. A working AI model on a data scientist's laptop is not a finished product, not even close.
Get this. According to Gartner's research, an alarming 87% of machine learning projects die before they ever reach a production environment. I mean, imagine spending months building this brilliant predictive model only for it to just sit on a hard drive because it simply cannot survive contact with the real world. That is the frustrating reality for the vast majority of AI initiatives today. And this massive failure rate happens because of a fundamental mismatch. A data scientist usually works in this isolated, super controlled environment, right? Clean data, smooth sailing in a Python notebook. But a live production server, that is high stakes, high traffic chaos. You're processing thousands of requests a second, dealing with incredibly messy live data, and trying to maintain strict enterprise security. The gap between those two worlds is exactly where AI projects go to die. So to bridge this incredibly expensive gap, the tech industry couldn't just use existing roles. They literally had to invent an entirely new discipline.
And that discipline is MLOps, short for machine learning operations. It sits right at the intersection of three fields that honestly do not naturally overlap: machine learning, software engineering, and traditional IT operations. An MLOps engineer is that critical missing link who ensures a model doesn't just look really cool in a demo, but is actually packaged up, deployed, and maintained reliably out in the wild.
You really have to ask yourself, what happens when real-world data suddenly completely shifts at 2 a.m. and your whole engineering team is asleep? Unlike regular software that mostly stays fixed once you read the code, ML models actually degrade over time as the world changes. Someone or something needs to be watching.
Let's make this real with a quick case study. Imagine a bank building a fraud detection system. The data science team builds an incredible model in Python that catches 95% of fraud. Awesome. But wait, the bank's production servers run on Java for enterprise stability. Boom, massive environment mismatch right out of the gate. Then, when they finally do deploy it, the model takes 3 seconds to evaluate a transaction. In the banking world, 3 seconds is an eternity. It is disastrously slow. And to top it all off, a month later, entirely new fraud tactics emerged that weren't in the original training data. The model's accuracy completely plummets, a phenomenon known as model drift. Without MLOps, this whole project is a total bust.
Okay, so how do we actually solve these deployment nightmares systematically?
We use the MLOps lifecycle. And this is fundamentally different from traditional software development because it is not a linear checklist. It's a continuous, never-ending loop. Data engineering cleans the data, moves it into model training, pushes it to deployment via automated pipelines, and finally into continuous monitoring. When the system detects that the model's accuracy is dropping, it automatically triggers the loop to start all over again, pulling in fresh data for retraining. Companies scale this loop through different maturity levels. AWS outlines 3 of them. Level 0 is basically just manual handoffs, literally tossing a model over the wall to engineers. Level 1 introduces automated training pipelines, so the model gets continuously trained with new data. And then the absolute gold standard is Level 2, fully automated continuous delivery. The algorithm retrains, tests, and redeploys itself without a single human touch. And that continuous loop is vital for one truly terrifying reason. It takes only about 48 hours for an unmonitored machine learning model to start serving stale predictions after a subtle shift in user behavior. If nobody's tracking that data drift, you could be giving terrible predictions to your customers for weeks before the business even notices a drop in revenue. Now, a lot of engineering managers look at all this and think, hey, I'll just hand these tasks over to my existing DevOps team. But the data shows that is a very, very costly mistake. While DevOps and MLOps do share tools like Docker and Kubernetes, their focus is totally different. DevOps is all about versioning and tracking code.
MLOps has a massively expanded surface area. Yes, you have to track the code, but you also have to track data versions, model artifacts, and hyperparameters. Where DevOps is looking at server health and CPU usage, MLOps is actively hunting for data drift and model degradation.
I absolutely love this analogy. Traditional software is a built house. Once you build it from the blueprint, it stays built. But ML systems, they are a house that continuously rearranges its own rooms based on the weather outside. Because of that insane shifting complexity, a standard DevOps engineer actually needs 6 to 12 months of intensive upskilling just to handle ML pipelines safely without causing a disaster. Because this exact intersection of skills is so incredibly rare, it has created one of the most lucrative talent booms in modern tech. The hard data from Core 1 for the 2026 job market is completely eye-opening. A senior MLOps engineer is pulling a base of up to $210,000. And at the principal level, you are looking at a base salary between $210,000 and over $312,000. When you add in equity and sign-on bonuses at top tech firms, total compensation is routinely blasting past the $300,000 mark. It is wild.
So what actually unlocks those top-tier salaries? Well, standard tools like Python and Docker are basically just table stakes now. If you want the massive offers, you need premium skills. Deploying large language models or managing massively complex GPU clusters can easily slap a $15,000 to $30,000 premium right on top of your base offer. LLM deployment is undeniably the hottest ticket right now.
These staggering numbers aren't a fluke. They're being driven by three huge forces. First, the MLOps market is experiencing a massive 41% growth rate. Second, there's a severe talent bottleneck. The Venn diagram of people who deeply understand statistical models and production-grade Kubernetes is incredibly small. And third, the massive tidal wave of companies trying to operationalize generative AI.
Which brings us to a really harsh reality for companies trying to hire. Hiring managers who try to pay standard DevOps rates for MLOps roles are just failing. Budgeting $120,000 for this role in 2026 is essentially below the floor for anyone with real, hands-on production experience. Companies that cheap out here just end up with an empty hiring pipeline and really expensive Jupyter notebooks that never actually do anything.
So I want to leave you with this provocative question to think about. Is your company simply building AI prototypes, or are you actually building AI products? Because literally anyone can build a model that works once on a laptop, but fully integrating MLOps is the absolute non-negotiable step to ensuring those brilliant experiments survive and thrive in the real world. Thanks for tuning into this explainer, and keep building.